Good morning. I would like to extend my sincere gratitude to the Smart Villages Conference Organizing Committee and the Business College of Athens for their invitation and the privilege of presenting the electronic health record application Obsidian MEDILIG. You may download the application free of charge from the official website at healis.eu. In the next 10 minutes, I will briefly try to present how I first became involved with electronic health record, how this application relates to the fundamental principles of the World Wide Web, how Obsidian MEDILIG works, why it differs from other similar health informatics applications, and finally we'll conclude with today's hottest topic, artificial intelligence, and how it finds application in the electronic health record. The conceptual foundation for the World Wide Web can be traced back to 1945. Subsequently, it was materialized as a computational application and then evolved into the contemporary internet infrastructure by the dawn of the 21st century. At this juncture, it is essential to establish a fundamental distinction between two pivotal concepts, information and data. While both paradigms operate with networked structures, as illustrated in the slide, their structural characteristics differ significantly. In information-based networks, interconnections exist between documents, commonly referred to as web pages. Conversely, semantic web network establishes connections between data that represent concepts such as individuals, geographic locations, or organizations. Within the field of computer science, this type of network is formally termed as knowledge graph. Since 2001, all major developments in semantic web, as well as in the field of artificial intelligence, have been fundamentally centered around data knowledge networks. Let us briefly examine the origins of MEDILIG. The individuals shown here in the current roles were part of the research team supervised by Professor George Stragelis during the period 2006-2009 at the Evangelismos General Hospital. During this time, we designed and implemented an electronic health record system containing clinical data alongside numerous specialized databases for specific medical conditions. Building on this experience with medical databases, MEDILIG was established in 2010. This is an open source electronic medical record system freely available online and has consistently recorded hundreds of downloads per month. To return to the distinction between information and data, it is important to note that healthcare professionals work with medical information, not raw data. However, for information systems to communicate with one another, as well as to enable the retrieval and analysis of information, it is necessary to encode information in the form of data. Organizations such as HL7 and OpenEHR focus on developing data encoding standards and clinical models. The Obsidian MEDILIG system stores data, but not in a conventional database, and in its current version, it does so without employing a standardized encoding framework. Regarding information, what primarily interests the healthcare professional as well as the patient is the clinical content. In a case, in a visit, in the patient's history, in the medication, in clinical examinations, and mainly how these may be correlated with each other, what the chronological progression, similar cases, how to perform searching, editing, and linking of the information. These are the capabilities provided in the functional features of Obsidian MEDILIG. In Obsidian MEDILIG, we process files just like in any other word processor, for example, Microsoft Word. The electronic health record is indeed a digital file on the computer. In this example, the patient's clinical visit is also a simple text file that may contain checkboxes and entry forms to be filled in. The clinical metadata that describe this file, visible in the right panel, are created and automatically filled in by Obsidian MEDILIG without the user to having to deal with them. Obsidian MEDILIG operates as an enhanced Markdown text editor. Here we open the patient's medical history in the left panel. And in the right panel, it is the same file in source mode, where we can see the code for toggle buttons and input text boxes. Clinical data that the user fills in are automatically recorded as metadata, as we saw in the previous slide. The medical history is initially created based on a template which the user can then edit in any way. Another example, we opened a clinical case. In the right panel, we can view a graph network that illustrates how this file is connected to the patient visits, to the patient profile, and the physician who monitors them, as well as to medical documents with multimedia that are related to it. Opening this file, there are internal links like web pages on a wiki website. By clicking the appropriate link, we are transferred, opens another file to read the related content. Here in the medical documents list, for example, if we select any of the green links, it will open a medical document for us. Therefore, although the documents in Obsidian MEDILIG are simple text files, when displayed in preview or reading mode, they are converted into interactive pages like those in a digital notebook. These pages can contain formatted text, code, images, videos, diagrams, tables, embedded data from other files. At the same time, we can interconnect these pages with each other, just like the nodes of a network are interconnected. Today, I consider that this is perhaps the most advanced, revolutionary form of creating and operating computer applications, which I named Live Notebook Network, LNN. A very characteristic example of such a page is that of a medical document. In Obsidian MEDILIG, a medical document is created from image, audio, PDF, video files that we have placed in a folder. The program will transfer these files to the patient's folder, as shown in the left panel, and will create tabs, as shown in the right panel, where in each tab box the content of each multimedia file is briefly described and displayed. Furthermore, the medical document will be automatically linked to the patient clinical case. In this way, the user can easily and quickly organize any medical information collected from other health information systems. Why then another attempt to create an electronic health record application? Because it is unique in many of its characteristics and on the whole as a general approach. Since time is limited, I try to document them on a single slide. I will confine myself to mention that Obsidian MEDILIG is extremely easy to install on any PC, can operate even offline, and it is the best possible way for security and protection of your sensitive personal data. There exist enormous capabilities for extension and upgrade and customization to user needs with minimal to no programming. It is ideal for research, for students and resident physicians, for patients, and for use in a doctor's office or a clinic. Here is a glimpse into the future. A specialized robotic physician that will handle all the tedious administrative work, endless document completion, data forms, and computer data entry retrieval. This would hopefully allow physicians to focus more on patient communication and better address patient problems, with the robot serving as a valuable assistant tool. Obsidian MEDILIG's functional design enables easy integration with AI engines to automate processes like scheduling visits and handling reminders notifications. These features are already built into the application. Thank you for your attention. Do not hesitate to contact me for any topic related to health information systems. I encourage you to recommend Obsidian MEDILIG to those you know or to try its functionality. After all, it is free and it will continue to be available free of charge.